This video is integrated 1. This is the chapter 3 homework, classwork number 2. So we are practicing more multiplying out polynomials, okay, using area models. So on 3-96, they are showing us one that's already ready for us to multiply out. And they want us to write the area as a product of the dimensions equal area as a sum of the parts. Okay, so area as a product of the dimensions equal area as the sum of the parts. So when I multiply this out, and x times a negative x is a negative x squared, this x is going to multiply both of these next ones also. X times y is an xy. X times 2 is a 2x. Now the negative 4 is going to multiply everything on top. Negative 4 times negative 4 is a positive 4x. Negative 4 times y is a negative 4y. And negative 4 times 2 is a negative 8. Now you combine like terms, but none of these happen to be like terms except for this 4x and this 2x. That's it. Everything else is not like. So our answer is going to be, well, let me first write it as area as a product. So this is area as a product. You don't have to write this wording out, but I want you to understand which one's the product and which one's the sum. So the product is the outside. The outside is x minus 4. Okay, that's from here. Okay, times this, which is a negative x plus y plus 2 equals, and now I'm going to add up all the inside, negative x squared, xy, my 2x and 4x together make a 6x, minus 4y minus 8. And that's your answer. Now, on the next section, I'll just kind of highlight as I'm reading. Each expression below represents the area of a rectangle written as a product, length times width. Sketch an area model for each expression on your paper and label its length and width. Then write an equation showing the area written as a product is equal to the area written as a sum of the parts. Okay, so this is what they want. Okay, so I'm going to draw a rectangle. Oops, not in highlight. And if you want, you can use the rectangle here. And in this case, I'm going to move it a little. I'm going to put it here. In this case, I need to count. I've got 1, 2 terms here. So I'm going to have 2 on either the top or bottom and 2 here. So it's going to be a 2 by 2. Okay. So I'm going to split it into 2 and 2. And then on one side, top or bottom, top or side, doesn't matter. I'm going to write x plus 3. And the other one, I'm going to go 2x plus 1. And then I'm going to multiply this out and get a 2x squared, 6x. 1 times x is x. 1 times 3 is 3. And then they want us to write area as a product equals area as a sum. So area as a product is x plus 3 times 2x plus 1 equal, and area as a sum, I'm going to combine any like terms, which is a x and a 6x. So I'm going to have as my answer here 2x squared plus 7x plus 3. I'm just writing it down here so I have more space. So that is what they mean by writing out an equation. Now, on the next one, I've got 1 term, and then I have 2 terms. So this is going to be a 1 by 2. Okay. I usually like to do my 1 down the side and my 2 across. So I'm going to put my 2x here, and I'm just going to move this over slightly, give myself a little more space. Okay. And then my x plus 5 here. So the 2x is going to multiply with x, which is a 2x squared. 2x is going to multiply with the 5, which is a 10x. So my area as a product is going to be 2x times x plus 5. That's the outside. Okay, that's what they're giving us in each of the problems. That's the product. The sum is 2x squared plus 10x. That's the area as a sum. On the next one, I have one term out front and I have two terms inside. So when I do this, I'm going to make this a little thicker. Okay. So when I do this, this is going to be a 2 by 1. So this is x. This is going to be a 2x. I like to put the minus right in front of the y so I see it. Now, x times 2x is 2x squared. X times a negative y is a negative xy. And so I'm going to write x times 2x minus y, because that's the outside, is equal to the inside, which is 2x squared minus xy. That's your answer. Okay, we don't just leave it in the box. We write it out as an equation. Okay, now this next one, we have one term, two terms here. The other one, I've got 1, 2, 3 terms. So I'm going to do a 2 by 3 or a 3 by 2. I usually like to make it longer this way. Okay. So I'm going to split it in half and then 3. So I'm going to write my 2x and my plus 5 here, my x plus y plus 2 here, and I'm going to multiply and get a 2x squared. Okay, so 2x is multiplying with the x, and now 2x times y is 2xy. 2x times 2 is 4x. 5 times x is 5x. 5 times y is 5y. And 5 times 2 is 10. And if I try to add up like terms, let's see, I've got a 4x and I have a 5x. That's it. So I'm going to write 2x plus 5 times x plus y plus 2 is equal to, and I am going to have a 2x squared plus 2xy. I'm going to add those two x's together and get a 9x plus 5y plus 10. And that is my equation. So I kind of went to the next line because I was running out of space. Okay, now on E, you want to be careful. It is not going to be a 2x minus 1 where I just square each piece. It's a 2x minus 1 times a 2x minus 1. That's what I need to write. So I'm going to have a binomial, 2 terms. This is what that means. And another binomial, 2 terms. So I'm going to have a 2 by 2 box. Okay. 2 by 2. And I'll have a 2x and then again put the minus with the 1, and here 2x and then put the minus with the 1. And so the top is going to be 2x times 2x, which is 4x squared. 2x times a negative 1, which is a negative 2x. Negative 1 times 2x, which is a negative 2x. Notice I got both of these twice. That's going to be a pattern we're going to see with these ones where it's the same thing being squared. Negative 1 times negative 1 is 1. And when I add up like terms, I have a negative 2x and a negative 2x. So I can write this out as a 2x minus 1 squared. That's perfectly fine. Is equal to 4x squared. My negative 2x and negative 2x add to a negative 4x and then plus 1. And that's my answer. Down the road, this is going to be something called a perfect square trinomial. I'm just throwing out that name to us. We will learn it down the road, but just start perfect square trinomial, forgot square. Okay, on the next one, I have one term and one term. So that's going to be a 1 by 1 box. Okay, so I'm going to have a 1 by 1 box. And one side's going to have 2x, the other side's going to have 4x. When I multiply this together, a 2x and a 4x multiply and give us an 8x squared. Remember, x times x is x squared. So this is going to be a 2x times 4x is equal to 8x squared. And that's our answer. Now on G, we have one term which we call a monomial times two terms that we call a binomial. So I'm going to have a 1 by 2. I'm going to do 1 by 2. Whoops, thought I had my shape. Okay, and so I'm going to have a 1 by 2. So I'm going to have a 2, and I'm going to have my 3x minus 5. 2 times 3x is 6x. 2 times a negative 5 is a negative 10. So I'm going to have 2 times 3x minus 5 equals, and I can't combine any of these, so that's going to be a 6x minus 10. And that's my answer. On the next one, we have a single term, which is a monomial, and then we have 1, 2, 3 terms. That's called a trinomial when you have 3 terms. So since I have a 1 term and a 3 term, that's going to be a 1 by 3. So I'm going to have my y here, my 2x. I put my plus in front of my y, I put my plus in front of my 3, so I see what it is. Y times 2x is 2xy. Usually we write it in alphabetical order. Doesn't matter if you put 2yx, that's the same. Y times y is y squared. Y times 3 is a 3y. So my answer is going to be y times 2x plus y plus 3 is equal to, I usually like to put my y squared first, 2xy plus y squared, but it doesn't matter. Doesn't matter as long as I have all 3 of those terms. Okay, now on this next page, it says, with your team, examine the equations you wrote for B, C, G, and H. This pattern is the simplest form of that mathematicians call the distributive property. Multiply the following expressions without an area model to write as sums instead of products. Be ready to explain your process with the class. So up here, the ones that they were talking about, let me kind of circle them in purple. B here, because you'll notice that I had a single term times a double term. C here. Okay, let me circle that whole thing. Because I have a single term times a double term. Next one, F is actually kind of the same idea. We have a single term times a single term this time. G, we have a single term times a double term. And H, we have a single term times a triple term this time. All of those, instead of drawing it out, we could have just distributed. That's what they're talking about. We could have just done that. Y times 2x is 2xy. Y times y is y squared. Y times 3 is 3y. That's what they're talking about. So over here, what we're going to do is we're going to distribute. I'm just going to rewrite it. And I am going to distribute the 2x with the 6x, which is a 12x squared. I'm going to distribute the 2x with the 5, positive 5, so that's going to be a positive 10x, and that's your answer. Okay, that's your answer right there. On the next one, I'm going to take a 6 times 4x minus 1. And again, I'm going to take the 6 times 4, which is going 4x, which is going to be a 24x. I'm going to take the 6 times a negative 1, which is a negative 6. And that's your answer. On C, let me just rewrite it. X squared 4x minus 2y. Okay, so I'm going to take x squared times 4x. You got to be careful here. This is going to be a 4x to the third. I'm going to take x squared times a negative 2y, and that's going to be a negative 2 x squared y. And that's your answer. Okay, we can do this with a box, but if you have a 1 by anything, it's really distributive. Okay, so this one, I've got some room above to draw, so I'm not going to rewrite it. This 7y times 10x is a 70xy. And 7y times a positive 11y is going to be a 77. Y times y is a y squared. And that's going to be our answer. And on the next one, I'm going to have a negative 5x times a 3x, which is a negative 15. And x times x, remember, is an x squared. And then a negative 5x times a negative 8, which is a negative 40 x. And those are our answers. Let me just do this so I don't highlight over the square. So basically, if you have a single term, which we call a monomial, times any polynomial, okay, all of these are polynomials. Okay, some of them are, so let me just put here one term, we call it a monomial. Two terms, we call it a binomial. Three terms, we call it a trinomial. And we don't really usually have special names for anything beyond that. We just call them polynomials of so many terms, okay? But all of these are considered polynomials. So if you have a single term monomial times any polynomial, you can use the distribute property. Or you can do the box like we did on the page before. Now on 3-99, they're asking us if order matters when we are multiplying these up. So it doesn't matter if I do x plus 1 and 7x plus 1, or 7x plus 1 or x plus 1. So let's say that, and notice it's the same two terms. So let's say that on one of them, I put the x plus 1 here and the 7x plus 1 here. And then in the other one, I'll do the other one in blue. Instead, I put the 7x plus 1 here and the x plus 1 here. Do I get something different? So in the first one, I'm going to take 7x times x, which is 7x squared, 7x times 1, which is 7x, 1 times x, which is x, 1 times 1, which is 1. And so what I ended up with when I did x plus 1 times 7x plus 1, I got 7x squared plus, and I'm going to combine the 7x and the x, which makes an 8x plus 1. Now in the blue one, I have x times 7x, which is 7x squared, x times 1, which is x, 1 times 7x, which is 7x, and 1 times 1, which is 1. And when I combine like terms, let's see what I get. So for 7x plus 1 times x plus 1, I get 7x squared plus 8x plus 1. So you see I got the same answer. So it doesn't matter if I put the x plus 1 on top or the x plus 1 on the side. I'm going to get the same answer, okay? And we call this the commutative property of multiplication. And that basically says A times B is the same as B times A. It doesn't matter which one I multiply first. Now, in this situation on letter B, notice that this is an x minus 1, and this is a 1 minus x. So are these the same? Does that matter? Okay. So let's try that. So let me do 1 in black and 1 in blue again. And let's see what happens. So for the black one, it doesn't matter which one I put on top, okay? So let's say I put my x minus 1 here and my 7x plus 1 here. Again, that doesn't matter. I could have put them either side. That does not matter. For my blue one, instead of it being a x minus 1, it's going to be a 1 minus x. So I'm going to put a 1 and a negative x. Okay. So what's happening is we are switching the minuses here. Are these going to give us the same thing? That's what they want us to see. So 7x plus 1. So when I do the first one, I'm going to get a 7x squared, a negative 7x. I'm going to get an x, and a 1 times a negative 1 is a negative 1. So when I had 7x plus 1, well, here, let me do this. I'll write it the way they wrote it. It doesn't matter which way I write it, but they had the x minus 1. Okay, that's what we're focusing on. And the 7x plus 1, I ended up with 7x squared. Negative 7x and x gave me a negative 6x, and then a minus 1. That's what I got. For the other one, okay, when I have my 1 and then my minus x, okay, so I switched the minuses. This is going to give me a 7x. 7x times a negative x is a negative 7x squared. 1 times 1 is 1, and 1 times a negative x is a negative x. So my like terms are going to be the 7x and this negative x. So for this one, if I have a 1 minus x instead of an x minus 1 times 7x plus 1, I ended up getting a negative 7x squared, a negative 6x, and sorry, a positive 6x, because it's a positive 7 and a negative x, and a positive 1. These are not the same, okay? Not the same. They're actually opposites. Because if I made everything here opposite, the opposite of a 7x is a negative 7x squared. Opposite of a negative 6 is a positive 6x. The opposite of a negative 1 is a positive 1. So they are opposites. So it's okay to switch what you're multiplying, but you cannot switch what you're subtracting. So subtraction is not commutative. Adding is. Okay. I'll write what is and isn't. Is not commutative. So if I take a minus b, that is going to not be the same as b minus a. What's going to happen is a minus b is going to equal the opposite of a minus b. Okay, that's what's going to happen. I am going to end up getting the opposite is what I'm going to be getting. Okay, but they are not going to be the same. So I'm just going to add a page, okay, just for information. We'll put these properties when I get back into our composition book, but when we're talking about commutative property, okay, commutative property. So for multiplication, A times B is the same as B times A. For addition, A plus B is equal to B plus A. So kind of as an example, if I did 2 times 3 or 3 times 2, I get the same thing. Both of them are going to give me a 6. If I take 2 plus 3, which is 5, or 3 plus 2, that's also 5. Both of them give me 5. Not commutative. What's not commutative is division, which we didn't show, but it is not, and subtraction. So division, A divided by B does not equal B divided by A. A minus B does not equal B minus A. So as an example, let's say I'm doing 10 divided by 5, that is 2. 5 divided by 10 is 1/2. These are actually reciprocals, okay, where they're flips of each other. For this, let's say I do 7 minus 5, which is 2, and then I do 5 minus 7, which is a -2. These are going to be opposites. Okay, and that's the end of this video.